All right, so welcome again everyone to this new session. And now today we are going to discuss this next chapter, that is linear programming or introduction to linear programming problem. Actually, this chapter is not important from the perspective of the JEE mains. This is only for CBSE board class 12th, and you can expect one or two questions in your JEE in your board's exam, and that will be around they can ask you the one mark question also, like in the MCQ type, or they can also ask you a 4 mark question or 6 marks question also. So let's start with this session. Okay, there are basic terms that we have to study first. So the first of all, we will be covering these topics today, that is the objective function. What is the objective function? Then we will be discussing the linear constraints. Okay, and then we will be discussing the optimal value of an objective function. All right. Okay, now it is working. Yeah. So actually, what happens is that this kind of programming, or we can say this kind of problems, linear programming problems, involves some sort of applications. Suppose that there is a guy. Okay, I'm just giving you some example here, because we are going to start with the questions only, right? So I'm just giving you some example here. Suppose that there is a guy who have a shop. Okay, who have a shop, and in that shop he has different sort of items. Okay, let's suppose this is having A items, then B items, then C items, let's suppose. Okay, and he said that there are certain cap for this A items that is, these are like let's say X rupees per kg, and these are Y rupees per kg. All right, and let's say this is Z rupees per kg. However, third variable will not be involved actually, because third variable is not in the syllabus. So let's discuss for the two variables only. So what do we say, that a shopkeeper is there who have two products A and B, and A is the price of A is X rupees per kg, and the price of B is Y rupees per kg. And his then the question was that the question can be framed like this: ki, suppose that in a month suppose that in a month he have sold some X product, some A product, some B product, let's suppose. Yeah, say that 100 products A. Okay, 100 B products he have sold in the month. Now they the question can be framed like this: they will ask you that how much is the maximum profit he can get. Okay, or how much is the minimum profit he can get. So of course, in a month there may be a day on which he will be getting he will be selling let's say 5 products, or he will be selling 4 products. So it will vary, right? But that has to that we have to make the let's say constant right now. Okay, that is not the part concern, but actually the part of concern is that by selling the 100 products of A and selling the 100 products of B in a month, how much, or much, or we can say the maximum profit he can get from this uh, these products A and B. All right. Similar is the case can happen when a person is there. Okay, this kind of problem we will be discussing. Similar the case can happen when a person is there and he have, let's say, $1 billion. Okay, just an example. $1 billion, and he want to invest this money. Okay, and he want to invest his money so that he can maximize his profit. Okay, here also what we are saying, he can, what are the maximum amount he can sold. So of course maximum profit he will get. No, if maximum amount he will be selling, maximum profit he will be getting. So in this case we can say that if the person is having $1 billion, then how he should invest this money so that he can get the maximum profit out of that. So if an intelligent person is there, he will be uh, you know investing his money into the multiple streams, like 5 to 6, or let's say up to 10 branches. Okay, and if a dumb person is there, then he will just keep the money and he will put in the bank, and that's it, he will relax till then, till the money is you know finished. So therefore there are so a person who is investing his money in 10 different streams, of course he is an intelligent one, and of course he will try to maximize his profit by this. Okay, so what is this thing actually? If he is investing in 10 different streams, let's suppose, so of course there will be some constraints to it. There will be, first of all, let me start with the objective function. If he is investing in 10 different stream, so what is his objective? His objective is that he should get the maximum profit out of these. Okay, so this is like defined like in this way, that what is the objective function, and that objective function actually we define this with the help of z. Okay, then the next condition is that if he is investing in the different 10 stream, then there might be some constraints for each stream. Suppose that he has given, let's say, $5 million to a company to invest his money. Okay, now this company will have also some constraints, like they will also take their commissions. Okay, and they will also say that there are some risk factor also involved in this. Okay, so by giving the 5 million, he can, after doing all sort of the risk calculations, company will say that we can give you 5.1 million in let's say one year. Okay, I'm just taking an example. So there are some constraints which he is getting in each of the streams. Okay, so if 10 streams are there, he will get 10 constraints, right? Now the last part is optimal value of an objective function. Optimal value means after applying the all constraints to all streams, okay, whatever the total profit he is getting, total profit, that is actually what is the value of optimal value of the objective function. Optimal means the maximum gettable output, or maximum maximum gettable output, you can say like this. Okay, so this is how these kind of problem works actually, in the money case also, in the investment case, right, in the shopkeepers. There are a lot of areas in which this can be used. So we will be starting with the questions only, and I will be discussing these terms with the questions only, right? So how do we solve actually? This chapter is going to tell you that how do we solve the linear problems. So of course these problems I am going to convert into the mathematical equations, like word problem what we have discussed in the elementary schools, and then these mathematical equations, linear equations, will be plotted on the graph. Okay, and then after plotting the graph, we will find out some sort of regions in which our solution will lie. Okay, so let's start with the question. I will tell you. You can see here it is saying that solve the linear programming problem graphically. So I'm not giving you the initially the word problems, right? This is simply nothing but a, everything is given here, right? So objective function is given, that is a maximize. Okay, objective function can be will be written as z, and it can be of minimize also, it can be of maximize also. That will depend upon the question to question. Okay, so you can see that here we are having maximize z is equal to 4x plus y. What is the x and y? X and y are the variables. Okay, subjected to constraints. These are constraints that x cannot be zero, x cannot be negative. Okay, x may be 0 or greater than 0, but it cannot be negative. Similar is the case for the y. So these are the constraints here, and now these are the linear equations, or linear inequalities actually, not equations. Okay, so what is the first part? First part is that draw these two lines on the xy plane. So this is, let's say, xy plane, this is x, this is y. So first thing is that we will say ki maximum z is given as 4x plus y. This is our objective function. This is our objective function. And then subject to constraint. Subject to constraint. Okay, which is nothing but x greater than equal to 0, y greater than equal to 0, and x plus y is less than equal to 50, and 3x plus y is less than equal to 90. So we just have to understand that how do we plot this. Okay, so we can just consider this as a linear equation. This is also as a linear equation for sake of drawing the graph. So x plus y is equal to 50. You can say, if you want, if you convert this line into the uh, double intercept form by dividing the 50 on the both sides, so x intercept will be 50, x intercept will be 50 and y intercept will also be 50. So this is 50, let's say, somewhere here, and this is 50 somewhere here. So 50 comma 50 is the point. So from here this line will pass. This line will pass like this. Okay. Yes, Ashutosh, tell me. Hmm. In the example you are saying, or in this question? Okay. In this question, the constraints are like x cannot be negative, y cannot be negative. They must have the value. Either they can be positive or they can be zero also. Okay, so they must be always greater than zero or equal to zero. This is the constraint here. Okay. You can say that there are limits that in order to maximize a function, x and y value will not be taken as negative. Okay. Hmm. So yeah, so this is the line we are getting from 50 comma 50, right? First equation. Second equation also again convert this one into the same format, that is divide this by 90 on the both side is equal to 1. So you will be getting what? X by 30 plus y by 90 is equal to 1. So what is the x intercept? 30. X intercept is 30 somewhere here, and y intercept is 90, so of course it will be above this line. So now you can join this, you can join these 2 points. This is the line, second line we'll be getting. Okay. But what about the region which will be our required solution? Because we have to find out the maximum, right? And maximum can be happen in in one of the region. Which region? Let's see. It says that x plus y is less than equal to 50. Now take any value which is lesser than 50, this line. Lesser than this line means take any random point which is uh, below this line. Suppose if I'm taking 30 comma 20. Okay, if I'm taking 30 comma 20, or let's say 30 only, x is equal to 30 I'm taking. Okay, so for x is equal to 30, what is the y value you'll be getting from this first equation? 20. So it means when you're taking x positive, y is also coming as positive. So that will be our required region, means below the line, below the red color line. Acha, suppose that in this line x plus y less than equal to 50, if I have taken the y x value as 60, let's say, that is above the line. Okay, random point we are taking, so we don't know. 2 points can be taken which is either above the line or below the line. Yes, Sujit, tell me. Yes. Hmm. Of course. I'm just telling you random point. So random point can be anything. Yeah. 0 comma 0. Of course, 0 comma 0 is obviously it will always correct. But I'm just telling you, this is the first example. No, this is the first example. So I'm giving you all possibilities that can happen to a student mind. Okay. Yeah. So yeah. If the line passes through origin, then of course it will not have any slope, right? Sorry, the slope will be what? One only, right? So in that case, yeah, you can say that. Because in that case, whatever the value of x you'll be taking, the same value of y will be there, right? But this will not happen, I guess. Okay. If huh, y is equal to x by 2 also, like some, and yeah, mx also, of course. But the thing is that if the line is passing through the origin, then it will not, you cannot tell that whether which type of region you are saying, which type of region you will be getting. Okay, which type of region, or we can say which side region you will be getting from this line. All right, because already 0 comma 0 is satisfying that equation. So yeah, just a second. So we were saying that if we're taking that 60, let's say x is equal to 60, so y will be equal to how much? Minus 10. So y is less than equal to minus 10 you will be getting. So or we can say, let's say if you are taking 60 comma what 60 comma 60, let's suppose. Okay, 60 comma 60 if we put here, so 120 means I'm just taking a random point which is above the line. So 120 is less than equal to 50. Is it true? Of course not, it is false. So means the area which is above the line, that cannot be our answer. However, the area that will be below the line, that will be our required solution. Means the area of this line, we can say area that is shaded region for this line should be the below the line. Okay, similarly in order to maximize the function, similarly for this line, second line, you can take any random points. If you are starting with the 0 0, so 0 0 will satisfy. Okay, let's take that 0 0 here in the second question. 0 0 means it will become 0 is less than equal to 90, which is true. Less than, so it is already there na. So we can say the line, the area will be again here also the below the line. So below the line, so the area which is common to both of them, this will be the area. Okay, let me draw with a different color. So our required region will be this, you can see purple color region, this one. Okay, so here this point we can say, let's say A, this point we can say, let's say B, this point we can say, let's say C. So the coordinate of B and C we already know. Coordinate of B and C we already know, that is 30 comma 0 is the coordinate of B. Coordinate of C is nothing but 0 comma 50. Coordinate of A we don't know, that can be find out with the help of solving the equation, right? Both the equation we have to solve, we can directly get the points. Anyone solved and can tell me the points here? What are the points? Mhm. Correct. So 20 comma 30 we will be getting by solving these two equations. Okay, now it says that, so these points are called as corner points actually. Okay, so I'll be telling you also key what are the points. These points will be called as corner points. Corner points, because why? Because these are the corner points of our feasible region. Feasible region is what? Which is the required region here in this case. So this is our feasible region, means this can give us the solution. This can give us the solution. So feasible region is there, that means the points that will be inside the feasible region will give you the feasible solution. So these points can give you the feasible solution, these 3 points. 0 0 can also be included if you want. Okay, 0 0 can also be included, but that will not make any sense because we have to maximize the value z. So let's see. So 3 points we have got, right? 3 points we have got. A as 20 comma 30, B as 30 comma 0, and C as 0 comma 50. And our maximum function z is given as, what is that? 4x plus y. So we will say that, uh, let's say the line was like this, right? 1 second. Hmm. I'm just drawing randomly. So this was our area, required area, right? This is point A, this is point B and C. So we have to check at each corner points that at which points we are getting the maximum value of z. Okay. Suppose if the point is lying inside or on the corner points. Achha, this point is also considered. So yes, I think already told you. Yeah. Okay. So the point which will be inside the feasible region or at the corner points will give you the feasible solution, and the point that will be outside the feasible region will give you the infeasible solution. Okay, there may be a condition that can happen. Suppose that instead of given that line x plus, what was the equation, x plus y is less than equal to 50, if they are giving greater than equal to 50, in that case this line will give you the above solution, means the region, shaded region will be the above this line, and that will give you the what, the point which will lie in the outside the region. So that point that is lying outside the region will give you the infeasible solution. Okay, the point which is inside the point that is inside the, oh, maybe it can happen. It can happen. Common region. Hmm. I just took an example, right? That's okay. No, it may happen. There may be a common region. Of course, it may happen. And it may also happen that there may be not any common region. So they will this that will give you not any solution. Okay. So that will be actually we say that infeasible region, or we can say infeasible solution. Of course, it can happen. Sometimes they can ask you like one or two marks question like that also. Okay. So feasible. What I'm saying, point that is inside the feasible solution will give feasible inside the feasible region, actually, sorry, point that is inside the feasible region will give feasible solution. Okay, so in this case feasible region is this one, and the points are a b c. So let's check the value. Okay, so at a 20 comma 30, what is the value of z we are getting? 4 into 20, that is 80, plus 30, that is how much it is? 80, that is 110. Similarly at a 30, sorry, b 30 comma 0, we'll be getting z is equal to 4 3 z 12, that is 120 only. Okay, and then we are going to find out at 0 comma 50. So 0 comma 50 will give you the value as, uh, 0 comma 50 will give you the 50 only, right? So which is the maximum value? This is the maximum value you are getting for the z. All right, so this point will give you the maximum value, and hence this will be our optimal solution, you can say. Okay, or maximum z solution. So therefore the maximum z, that is equal to 120, occurs at b point, that is 30 comma 0. Is that clear? Okay, and one more thing. Yeah, tell me. After that we have to find out the maximum z value, right? So as I said, inside the feasible region you will be getting some feasible points. Okay, like these corner points also included. So these point, one of these point will give you the maximum z value, and that is actually occurring at b point. 0 comma 50. No, no, no. 0 comma 50, how? In this we have to put na, in the z value. Okay, in this z value we have to put these points. All right, so actually these points are called as corner points. Okay, these points are called as corner points. Okay, and the optimal value occurs at the corner point. If optimal value occurs at occurs at corner point, then it is called as corner point method. This will be called as corner point method. Okay. You can say for feasible region is if the optimal solution is occurring at the corner points, then this will be called as corner point method. But actually we are solving the corner point method only. Okay, so this is it. These are the basic parts that we have discussed. A linear function involving some variable whose value is to be either minimized or maximized to the given constraint. It is represented by z, and that is given by in this format, linear format, ax plus by. Then linear constraints we will be having, that is some limitations or restriction on the resources. Okay, in the form of linear equations. Then we will be having optimal value of an objective function that we have already found out. So maximum or minimum value of an objective function can happen, and this will be known as optimal value. All right, I hope that this thing we have already covered. Now feasible solution also I have covered. Set of values of variable, set of values of variable that satisfy all the constraints is known as feasible solution of the system of an equation. And then what is the optimal solution? See, feasible solution and optimal solution is different. Feasible region in which you will be getting the feasible solution from the points. Okay, however the optimal solution will be that solution that will give you the maximum or minimum value according to your maximum according to your objective function. Okay, so feasible solution which leads to the optimal value, or we can say maximum or minimum value of z of an objective function, is known as optimal solution of the system of an equation. I hope that this is clear. Can we go the next part? Okay, now we are having the next question. Let's quickly solve it. Now this, in this case, solve the linear programming problem graphically they are saying, and minimize z. This time they are saying that minimize z means we have to check at the corner points of the feasible solution at which point or at which coordinate we will be getting the minimum value of z. Okay, so minimum z is 200x plus 500y. Now the equations which are constraints, that is x plus 2y. So I am just considering the equation, right, because we have to plot them. Ultimately is equal to 24. Now in this case, what are the the intercept you will be getting? For x you will be getting 10, and for the y you will be getting 5. So at x is equal to 10, y will be 5. So the line will be like this. Okay, here you can consider 10, let's say. Okay, by the double intercept form it is very easy to draw the graph. You don't have to make the table every time. Right, then for the second one, if you divide it by 24 on the both side, it will become x by 8, then it will become y by 6 is equal to 1. So at x is equal to 8, y means x intercept is 8, so somewhere here, and y intercept is 6, so little bit above. Okay, but I'm showing you at a certain distance, because so that you can differentiate them easily. This is 8, this is 6, so the line will be like this. Okay, this is the line. Now we have to find out the solution. So our solution will be totally depend upon these inequalities. Okay, so for the green color one, let's say this green color one is nothing but 3x plus 4y is equal to 24, and this red color one is just a second. This red color one is the line which is x plus 2y is equal to 10. The same method we'll be going to do, that is check the random points. Check 0 0 first, right? This time you can directly check 0 0 because 0 0 is below the red line. So 0 0 we can check. If we put 0 0 in this part, in this equation, first one, so 0 plus 0 is greater than equal to 10. Is it true? So it is not true, right? If it is not true, then the region which is below the line, that is actually 0 0 side, will not be the solution. However, the region will be above the line. Getting this point? Because it is not getting true. Similarly, for the green color line, you can take the 0 0. Okay, for the 0 0, if you take here in this part, this will give you 0 plus 0 less than equal to 24, which is true. So of course, so for the green color line, we will be getting the region which is below the line. Okay, so for the green color, that is below the line. Now what is the common region? Which is the common region we'll be getting from here? The common region will be this one. If you can see, this one will be the common region, the blue color one. So this time I can say the corner points are like these points. This is A, let's say this is B, this is C. So B point is already we know, that is nothing but 0 comma 6, right? And this point is 0 comma 5. The A point we don't know, which we can find out by solving the equations. Okay, point of intersection. So what is the point? Anyone solved it? 4 comma 3, right? So we'll be getting 4 comma 3 after solving this. A 4 comma 3. So that's it. The question is done. Now this is our feasible region. This is our feasible region, and the corner points we already know, A, B, C. So we have to check the value of Z, minimum Z actually. So minimum Z at 4 comma 3, this will be 200 into 4 plus 500 into 3. That will be coming as 800 plus 1500, that is 2300, I guess. Yes, 2300, right? Similar is the case with the 0 comma 6. So Z value will be 200 into 0 plus 500 into 6. That will give you the 3000. Similarly, the third one will give you what? 200 into 0 plus 500 into 5, and that will give you the 2500. So out of this, the minimum value you are getting is at A point or at A coordinate. So that will be our required solution. Means that will be our minimum value. So the minimum Z is equal to 2300 occurs at A 4 comma 3. Okay, that's it. This is how the question is done in this chapter. So one question we have done in which both the area are below the line. One question we have done in which for one of the line the area is above the line, and the second the area is below the line. And now we are going to discuss that when the open area is there, okay, that we called as unbounded. See, this is feasible region, but we also can say that this is bounded feasible region, right? This is bounded because it is bounded from every point. Okay, it is closed actually. But however, this may happen that you can get the open, or that will be called as unbounded feasible region. So let's discuss the question based on that only. So this is the answer: x is equal to 4 and y is equal to 3. Corresponding value of z is 2300. Next question. This time we are having the constraint 2x plus y is equal to 8. I am writing equation, okay, in order to draw the graph directly. This is 10, and the minimum z is again saying minimum z value you have to find out 50x plus 70y. So what we will say, this is x, right? This is y, and then again we will convert this into the double intercept format. So that will be give you divide the 8 by both side, divide the 8 on the both side, you will be getting x by 4 plus y by 8 is equal to 1. Similarly for this, divide the 10 on the both side, x by 10 plus y by 5 is equal to 1. So first line will give you what? 4 and 8 intercept, that is 4 here and 8 here somewhere. Okay, so join them. Similarly, then x10, so somewhere here let's say x10, and y5, so y5 will be definitely somewhere here. Let me choose the different color. So this is 5. Okay, so there are 2 points you are getting here. Sorry, 1 point, 1 point of intersection we are getting, this one, and so the same thing we are going to repeat what we have done just now. First of all, find out the feasible region. First of all, find out the feasible region. So this point, okay, first of all let's find out the feasible region. So for the first line, it is greater than equal to 8. So for the greater than equal to 8, just take the random point again. So that is the first line. Let's say this is L1 and this is L2. So this is L1, red color one is L2. Red color one is L2. So for L1, if you take 0 0 origin, will it satisfy? 0 comma 0 plus 0 will greater than equal to 8. It is not satisfying, that is false. So above the line, the area will be above the line, shaded region will be above the line, or we can say feasible region will be above the line for this line. Similarly, for the second equation or second inequality, again you can take 0 0, right? 0 0, 0 plus 0 will give you equal to 10, greater than equal to 10, which is not true. Again it is false, and it is also false. So again it is also above the line. So what should be the common region then? The common region you will be getting is this one. Common region you will be getting the this one, above the line, totally above the line, from both of the line. Okay, don't take the common region to the negative portion. Okay, this is only the positive part. So this is how you're getting the positive region. Sorry, this is how you're getting the region which is unbounded. So in this case you will say that this is unbounded region. This time I'm this at this point I'm just saying unbounded region. I'm not saying unbounded feasible region, because feasible region will be called, it will be called as if it is giving you the minimum z. Okay, and those, that minimum z is actually occurring at the, of course again we have to check the corner points only. So in this case, this is the first corner points you will be getting, this point. Second corner points, let's say this is B point, and this is the third corner points, let us see. So this will become 10 comma 0, directly we know, and this also we know 0 comma 8. This we can find out by the solution of the equation of line. Okay, so when you solve it, anyone have solved it, you can tell me. I think you will be getting 2 comma 4, right? You will be getting 2 comma 4. Yeah, so 2 comma 4 will be the point B. Now we have to check whether it is giving us the minimum z or no. So A point, okay, this is A. So A point is 0 comma 8, B point is 2 comma 4, C point is 10 comma 0. Let's check the z value. So z value at this 50 into 0 plus 70 into 8, that will give you what? 560. Okay, similarly z is equal to, at this point, 50 into 2 plus 70 into 4, that will give you 380. Similarly for this z, 50 into 10 plus this will become 0, right? So 50 only. So the minimum value, sorry, not 50, 500, no? 50 into 10, yeah. So you can see that the minimum value is occurring at B point, that is 2 comma 4, that is 380. So in this case, since it is occurring the minimum value, so we can say now ki unbounded, this is unbounded region and also the feasible region. I told you that the region can be unbounded also or bounded also. In this case we are considering the case of unbounded region, and yes, it is a feasible region because it is giving the optimal value of z. Okay, optimal value of z is nothing but this value. So therefore you can say, yeah, you can verify. Of course, we have to. Yeah. Yes. You said it correctly. So yes, one more thing that we should verify also. Yes, you said it correctly. We should verify the points also, that whether they are giving you the, whether they are satisfying the inequality or no. Okay. So let's see that. So if we say that 50x plus 70y, because because, yes, actually, yes, you said it correctly, but the thing is that in the bounded region you are clearly able to say that these are the corner points. Okay, but in the unbounded solution there are infinite number of points here. All right, so along with the corner points, it may happen that some other, at some other point also they are giving you the minimum value, right? So in that case we have to see that whether it is true or no. So what we are saying, z is equal to 50x plus 70y, it should be what? less than 380. Okay, it should be what? Less than 380. Minimum value of z is 380 na. So 50x plus 70y should be less than 380. So if you check at any point 0 comma 8 2 comma 4 10 comma 0, the all point will satisfy. The all point will satisfy except this point, because this is the corner point which is giving you the optimal solution. Okay, so minimum value is occurring at 2 comma 4 only. Now it is fine. So we have to check actually. Sorry. Hmm. Hmm. Uh-huh. Hmm. But but the thing is that, thing, yes, yes, tell me. Mhm. There is more solution. I said no solution. All right. Uh, let me tell you one more thing. Actually, what we say, you are saying correctly, but the point is key. When the two lines are involved, two linear equations are inequations are involved here, so we always talk about the point which is common. Okay, we talk about the point which is common. So in this case, these are the corner points. That's okay. These are the corner points, but they are not giving us the minimum value. The minimum value is occurring only at B. So whatever the point we will be getting, even though in the green color region, that point should be the common to both of them, or we can say the point of intersection. Huh. Mm-hmm. Okay. Should not. No, this is. I have not said that you have to draw this line. No, this is just. But you have to check the function also, na. The function is giving you what? How much value? The value is also important. No, optimal value is also important. What is the what is the target? What is the target for this question? The minimum value. Okay. So minimum value will be occurring if, yes, you are correct. If suppose that it was happening in some case ki 0 comma 8 is also giving you the minimum value, and 10 comma 0 is also giving some minimum value which is nearly around 380, let's suppose. Okay, nearly around 380. In that case it will have multiple solution. Okay, that's what you all want to say. Okay, so suppose if we plot this. Okay, suppose if we plot this, how much it is? 7 point something. So somewhere here. And y 380 by 7, that is 5 point something, so somewhere here, right? So how will be it will be like it will be passing through this point only. Huh. Mm-hmm. Huh. Okay. Mm-hmm. Yes, tell me. I was just saying that this line will pass through this only, and that point is actually also a common point. Of course. Hmm. Okay, got it. Now, okay, let's hmm, let's go to the next part now. Next is the next question again. Yeah. Sorry. Okay, they were saying ki since the region is unbounded actually. Okay, so there may be a infinite number of points that can give the minimum value. So how do we say that whether this point is only the point which is giving the minimum value? So what should we do then in every time in case of the unbounded region, we should draw this value. We should draw this equation which is the minimum z equation. Okay, and when you draw this equation, if it is passing through this intersection point, which will definitely passing that through that point only at which you are getting the minimum value according to the initial solutions what you have done for the 3 points. So okay, so if this is passing through this intersection point, then you will not have the different region, which is actually which is actually make the question ambiguous, right? That if this equation, if this line also is intersecting these other two lines at different points, then the region will be totally different. Okay, in that case the solution will also be different, but that cannot happen actually. Okay, that was the point actually ki, the if you, even though if you want to check it, this line will be definitely pass through this point of intersection. Okay, so means optimal solution is one value only, which is this point. Ha, because that was the bounded one. Okay, in the bounded you have the specific points at which you have to check. Okay, next question. So this question I think you can try the same kind of question is there, right? And finally the answer is that only 3 comma 380 only at 2 comma 4. So this time we are having three lines. Okay, what are those lines? First is x is equal to y. Second is x by 10 plus y by 10 is equal to 1. Okay, and the third is x by 60 plus y by 3 by 60 will give you what? 20 equal to 1. Okay, I have written this in the double intersect form directly so that you can draw it now. So x is equal to y. X is equal to y. I think just a second. Rather, we will should write as x minus y equal to 0. Let's say. I think there is a mistake in this part. Just a second. That's correct. Okay, correct, correct. So x is equal to y line, so you already know. That's why I said earlier also, if you are considering two lines only, then y is equal to x line will make problems in the solution. Hence, they have given in the three lines here, so that the common region will be there. So first line will be this one 10 comma 10. So 10 comma 10, let's say somewhere here. Oh sorry, let's say 10 comma 10 here. So this is the line, second line. Similarly, the third line is 60 comma 20. 60, let's say somewhere here, and 20. So 20 will be somewhere here. Okay, so this third line will be like this. Let me draw with a different color. Okay, now you have to check the region again. You will check the region again. So when you check the region, you can see x minus y is equal to 0, or x minus y is less than equal to 0. This one. If you check at 0 0 also, I think 0 0 is not work because it is already passing through the origin. So rather we should take some random points above the line and below the line. So let's suppose I'm taking 2 comma 2 comma 5. Okay, just a random point which is above the line, right? So 2 comma 5, 2 minus 5 minus 3 less than 0. Yes, it is true. If it is true, then above the line is the region required for this line. Similarly with this one, for this we can choose the 0 0. So 0 0 will give you the greater than equal to 10. Not true, false. The second line which is passing through the 10, false means above the line. Again for this also the above the line region. Similarly, x plus 3y is less than 3 is equal to 360. Again we can take 0 0, and 0 0 will satisfy because 0 plus 0, or we can say 0 is less than equal to 60, which will satisfy. So the region is this one below the line. So the in overall the common region you will be getting, this one. Okay, so you have to find out this point A, this point B, this point C is already known, this point D is already known, and then check the points, find the values. Okay, so I'm giving you I'm leaving it to you, or if you have found out already, then you can tell me the coordinates of AB, because C though we already know. C point is 0 comma 20, and D point is D point is 0 comma 10. And if anyone can tell me about the points A and B after solving the equations. 5 comma 5 and 15 comma 15, yes. So this is 5 comma 15. This is 5 comma 5, correct, right? So now just find out the points. So let's say A is 5 comma 15, B is 5 comma 5, C is 0 comma 20, and D is 0 comma 10. So let's find out the Z value on each of the points. So 3x plus 9y, right? So 3 5s are 15 and 135. How much it is? 15. 60? No, 1 second. 9 and 15. 15, 15, sorry, yeah. Okay, so it will become 180 then. Hmm. Similarly, 5 comma 5 will become 15 plus 45, that is 60. 0 comma 20 will become 180 again, and this will become 90. So you can see at the 2 points you are getting the optimal value. Okay, maximum value. So we can say on the entire line, that is which is the line on which we are getting the points 15 comma 15. This is the line. So on the entire line, this we can say that will have the maximum value, and it has multiple optimal solution. That was the whole motive to give this question. Multiple optimal solution can also be happen. Okay, these 2 points. Right, now let's quickly do one word problem. Okay, one word problem. This is a very important question. You will understand a lot of things here, and then we will wrap the session quickly. So this is the answer, as I told you already. ABCD you can accordingly mark. The question says that this is a little bit bigger question. First of all, we have to study, we have to read this question. Actually, a manufacturer has three machines, 1 2 3. Okay, Roman, in the Roman they are written, installed in his factory. Machine 1 and 2 are capable of being operated at most 12 hours. At most means they are saying maximum 12 hours it can work, more than that it cannot work, or less than that it can work for the zero also. Okay, this at most is actually giving you the condition for inequality. I will tell you how. Whereas machine 3 is being operated at least 5 hours a day. At least 5 hours a day means minimum 5 hours a day. Okay, maximum it can go on. Similarly, he produces only two items M and N, each requiring the use of all three machines. The number of hours required for producing one unit of each M and N on the three machines are given in the table. So you can see the number of hours required on the table is given. That is 1 hour is required on the first, when you are saying that for M items, and 2 hours is required on the second, and 1 hour is required on the third machine. Right? So actually they are giving you the constraints. They will give you the constraint equations, or we can say inequalities. The next one, he makes a profit of 600 rupees and 400 rupees. They will on the items M and N. So M and N items we are writing as X and Y. So what is this? This is giving you the objective function. So by the reading the word problem, you must have to identify actually which is the objective function and which are the inequalities or constraints, right? So in this case, this is the objective function. This will be the giving the objective function. Then it is saying how many of each item should he produce so as to maximize the profit, assuming that he can sell at the all the items that he produced. Means he's selling all the items whatever he have produced, and then we have to maximize the profit. What will be the maximum profit? This is the question. Okay. Now let's solve this. So as you can see, these are the this is the table given. They are saying that the yeah, this is the table they have given, and they are asking that to maximize. They are asking that to maximize the Z value. And what is that maximum value Z? You can see 60 on the product M means X. So sorry, 600 on the X. So 600 rupees he is getting on the X product, and 400 rupees he is getting on the Y product. So that's why the maximum Z will be 600X plus 400Y. That's it. And now we have to write the constraints. Subject to constraint. Subject to constraints. First constraint is that, of course, X is greater than equal to 0, Y is greater than equal to 0, because negative selling cannot be done, right? Negative production cannot be done. Then the first equation we are going to write. What is that? We'll be getting X plus Y, because the question is saying what? You can see he produce 1 and 2 are capable of being operated at most 12 hours. At most means we are going to use the sign as less than equal to 12 here. So X plus 2Y is less than equal to 12. How this X plus 2Y? Because on the 1 and 2 they have said, so 1 and 2, 1 is there, so 1 into X, 2 into Y. Sorry, 1 into X, 2 into Y, this one. This is the first equation. Similarly, the second one will be what? 2 into X plus Y, which is less than equal to 12. Okay, both the equation will be made this from this. The first one is from these two expressions, second one is from these two. This is X, this is Y. Getting this point? And that's then the last one. Then the last one we can get from here, which is nothing but X plus 1.25Y. X into 1, X only. Then condition for this is also given. It is saying where the machine 3 is being operated at least for 5 hours a day. At least for 5 hours a day means we have to write this as a greater than equal to 5. Now there are 3 constraints again, and then plot them, get your points, find out the answers, find out the optimal solution or maximum Z. Okay, so I am leaving it to you. After this it is easy. Draw the graph and find the maximum Z. You will be getting the feasible bounded region only. Don't worry, in this question there will be no unbounded region. Okay, so I am giving you the answer for this. Answer is 4000 is correct. Yes, 4 units of each. 4 units of each. You will be finding out the value. X is equal to 4, Y is equal to 4, Z will be equal to 4000 rupees. That will be the maximum value. Okay. Last question of today's session. A furniture dealer deals in 2 items, chair or tables. He has 5000 rupees to invest. Okay, so you can see he has total 5000 rupees and 2 types of items are there. Let's say chair is X and table is Y. Okay, 5000 rupees to invest and a space to store 60 items. Okay, a table cost him 250 rupees and chair is 50 rupees. So 250 into X, 50 into Y. Okay, he can sell a table at a profit of 50 rupees and chair at a profit of 15 rupees. How should he invest his money in order that he may maximize the profit? Formulate the LPP and solve the graphically. So first you will have to formulate the LPP. Acha, wherever the profit term come, it is saying he can sell a table at a profit of 50 rupees and a chair at a profit of 15 rupees. So this will give you what? The maximum Z. Okay, because it is already saying maximize the profit, so maximum z value can be written as, for table you have written the means number of table we are writing x, so let's say 50 into x total money of the total profit of the table. Total profit of the chair will be what, 15 into y, and that's how we'll get the maximum z function. All right. Right. Now next thing is that uh, maximum space for items, maximum space for items is 60. So it means whatever, subject to constraint, we can say subject to constraints. So maximum space for two item is 60, means whatever the total number of chairs plus total number of tables you will be having, that can only be stored if they are having in total 60 items. So that means less than equal to 60. This can be your first constraint. Similarly, second constraint you can find out by the price is given 250 rupees, table cost him 250 rupees, chair cost him 50 rupees. So the next equation can be, okay, so here also you can write in the table that this is 250 cost, profit is 50 rupees, chair is costing 50 rupees, and this is costing 15 rupees. Okay. And oh, yes, someone want to ask something? Okay, so maximum z is 50x plus 15y, right? And constraints are, for the cost we will be writing, for the store capacity is 60, so x plus y is 60. For the cost 250x plus 50y, you can see 250 rupees per table, 50 rupees for the chair. 50 into y is less than equal to how much? Total rupees they have given, total investment is 5000 rupees, so this is less than equal to 5000 rupees. Okay, that's it. And of course, the basic constraint, x is greater than equal to 0, y is greater than equal to 0. Plot them, get your answer. Right? So I'm leaving it to you again. Maximum value you have to find out. So the answer I'm selling, answer I think I have here written. So answer you will be getting 10 tables and 50 chairs. That is x value is 10, y value is 50, and he will get the maximum profit of 1250 rupees. That is the maximum z value. All right. Is it clear? Or any doubt is there? The graph you will draw and you will get the solution. Okay then, so this is it for today. Hope you all enjoyed it. Yes, one second. So yeah, so we can keep the session up to here now. So we'll wrap the session now. Okay, one second.